Hey everybody, how's it going? Hope that you had a good weekend, that your first week of online classes went well for you, you're getting everything figured out, still safe and healthy. For my part, I'm really craving a burger, but I haven't eaten out in about 2.5 weeks. And when I went to the store over a week ago, they were all sold out of ground beef. So yeah, first world problems here in West Lafayette, but otherwise doing well. I've got two announcements. First is that we are going to have a live problem session on Thursday this week, April 2nd, from 8 to 9:30 Eastern Daylight Time. I know that that doesn't accommodate the time zones for everyone in the class. I know there are a handful of you who are in Europe and some others who may be in the middle of the night at that time. But the week after, we will rotate the problem session so that it's in the morning Indiana time, hopefully better for those of you in Europe or in Asia. And then also it'll be recorded, and so you'll have an opportunity to check it out either way, even if you don't get a chance to read it live. You may have just seen my cat. Well, I guess she just got down from my lap. But anyway, so that will be posted. There will be a link to the WebEx meeting that I'll put on Blackboard as well as the Google Drive for Thursday. The other thing is that homework 4 is due not this Wednesday, but the Wednesday after on April 8th. So that'll be due at midnight Indiana time, just like usual. Okay, today we are talking about cost effectiveness analysis, which is not covered in the textbook. There is a reading assigned associated with it, and I've posted it on Blackboard in the additional readings folder and on the Google Drive in the supplemental materials. It's a report from the Institute for Water Resources, which is a branch of the U.S. Army Corps of Engineers that talks about cost effectiveness analysis and gives the example that we're going to talk through today. But before we launch into it, I want to just talk briefly about some examples of non-monetary impacts that motivate the need for cost effectiveness analysis. Those are called ecosystem services, and I alluded to it the other day in my previous video talking about building a dam, how things like the recreational value of fishing or boating or hiking would be something called an ecosystem service. And what these are the beneficial outcomes or the positive impacts that we get from the ecosystem functioning. If we're going to use it in an economic analysis, we require that we have to have some interaction with the human system in order for us to derive value from it. And there are 4 main categories. The first is a provisioning ecosystem service, which are the products that we actually obtain directly from the ecosystem itself. These are things like lumber or minerals that are mined from the ground, things like that. The others are regulating services, supporting services, and cultural services. Regulating services are those that are promoting regulation of the natural environment. So an example of that would be the fact that groundwater, as it filters through the ground, actually naturally filters the water and cleans it up for us. Supporting services support other ecosystem services. So that would be something like the fact that bees and butterflies pollinate flowers in order to help trees grow or vegetation to grow. And then cultural ecosystem services are things like we mentioned, the recreational value associated with having a dam where people can go and hike around the lake. Some services, like provisioning services, are traded directly on markets. Here you can see lumber or water. We have markets for those, so we can just take the price that they trade at and scale that up by the amount of lumber that a particular ecosystem is providing or that a project would produce, or the amount of water that could be taken from the reservoir that we're building and extracted for drinking water or agricultural irrigation water, and just multiply that by the unit price in order to get the value. However, some are more complicated than that. And so here we have a regulating service, which is a barrier island on the left. You can see that that barrier island would naturally produce a barrier, like it's called, against storm surge for properties and assets that are inland and actually kind of on the coast as opposed to on that island. On the right, you can see this giant flood wall that's been constructed, which provides the same purpose. Okay, so it's providing the same service of flood protection as the barrier island, but through technological or engineering means. So this is an example where technology could change the value of an ecosystem service, just like the salmon cannon did a few videos ago. That as technology changes, the price of providing that particular service could change, and so then the value that we would ascribe to that service also changes. Cultural services like recreation and the spiritual value that some people associate with nature, those can be very complicated to try and put a price tag on. Often we would use something like a revealed preference study or studies of willingness to pay, just like we talked about earlier in the semester, in order to try and put a price on those services. However, it's going to be complicated no matter what. There's a lot of uncertainty. The value of it may vary from person to person or from society to society in different parts of the world. And there are a lot of other questions about what exactly we should be measuring. So should we be thinking about direct benefits or also thinking about indirect second order effects? Or if a service is only partially contributing to a particular impact, should we count the whole value of that impact, or how do we split it up? We had that same allocation and attribution issue that we talked about one lecture earlier in the semester. So there are a lot of nuances to this that make it really complicated. And so economists think, well, we don't necessarily need to put a monetary value on everything. Sometimes we might be able to do an analysis that just takes into account a measure of the impact itself instead of the value of that impact. If we were going to try and assess the value, then, well, to get the net benefit of some sort of a climate change adaptation project on ecosystem services, we've got a lot of different steps. First, we're going to collect data about the current baseline environment and the level of ecosystem services that are already being provided, and then try and estimate what's the total and the marginal or the incremental value of services that would be changed by the project. We need some sort of a simulation model of the system that it's going to allow us to tell how the impact is going to change as a function of the project we're putting into place. We're going to simulate that. We're going to translate it into the net benefits using those marginal value estimates. And you're asleep. I really just need to wrap it up. So, cost effectiveness is what we're going to use in these types of cases. When the benefits of a project are really difficult to monetize, or it might be more uncertain to put a monetary value on something than to just measure the direct impact itself. If that's the case, then we're just going to skip the effort of putting a monetary value on it in the first place and follow this alternative approach. So this is really common in the case of projects with environmental impacts or impacts on mortality in cases where we don't really want to use a value of a statistical life for whatever reason, or for public works projects where we're just thinking about trying to provide as many miles of roads or as many miles of pipeline as possible for a given amount of cost. So that's a key to the type of decision rule that we're going to use here, is that our goal is to identify what's the least cost solution for any possible level of output. We don't necessarily have a dry and fast decision rule like the net present value has to be greater than zero. in order to determine if the benefits outweigh the cost because they're measured in different units. So we're not converting the impact to monetary value, so we don't know if the net benefit outweighs the net cost. A really simple but abstract example is as follows. If we have a study that has 3 different alternative plans for how we can restore a certain number of acres of habitat, Plan A will restore 1,000 acres at a cost of $1 million. Plan B will restore 950 acres at a cost of $500,000, and Plan C would also restore 950 acres, but at a cost of $750,000. So the question is just which project would we prefer? It's just a project selection example like any other that we've talked about in Chapter 6 and beyond. And if we're thinking about this, then B and C provide the exact same level of environmental output, but Plan C is a lot more costly than Plan B. So if all of the other impacts are equal, we would choose Plan B. Plan B, however, is providing 95% of the output of Plan A, but at 50% of the cost. So there is a difference in the impact. It's smaller, but only slightly smaller. But the cost is way smaller. So in this example, it's likely hard to argue that the additional 5% of habitat that you could restore with Plan A is worth doubling the cost of the project. The reading gives 9 easy steps for doing a cost effectiveness analysis. And if you think about it and go back to Chapter 1, it's really consistent with the guidelines from the textbook about doing a general economic analysis. First, we're starting out by displaying what our outputs and costs are from different projects, trying to identify different measures that we could potentially combine, and that's really similar to developing our set of feasible alternatives from Chapter 1. Then we're calculating our outputs and the cost of different projects. That's like developing the outcomes and cash flows for each of our alternatives. We've got some other steps here that are very similar to just doing the analysis in some way, and then comparing alternatives to each other, and then finally selecting which one that we prefer. That's the basic concept behind cost effectiveness analysis, that we want to conduct it in a fairly similar way to what we've done as an incremental analysis using benefit cost ratios or other metrics. The only difference being that our objective is to identify the least cost solution for any given level of output, and that we don't have a hard and fast rule that tells us where exactly the cutoff point is beyond which a project is no longer justified. We'll walk through a more complicated example to try and illustrate that, make it a little bit more concrete in the next video.